All right, let's just jump right in. If you're a student tinkering with AI right now, you know how amazing it is. I mean, the barrier to entry is just gone. You can spin up a really cool AI app, sometimes without a single line of code, and make something that honestly feels like magic. But here's the thing, that wow moment, that first demo that actually works, that's just the starting line of a much, much longer race. And this quote just nails it. This is what people in the industry call the last mile challenge. It's this massive, and I mean massive, gap between a prototype that's cool on your laptop and a real professional product that people can actually depend on. So the big question is, how do you get across that gap? How do you turn your weekend project into something real? So here's how we're going to break it down. We'll start with this last mile problem and how to get the right mindset to tackle it. Then we'll build a checklist for what makes an AI actually good. We'll talk about how to test these things, and finally, why this job is, well, basically never finished. Let's do it. Look, the first step to closing that last mile gap has nothing to do with code. It's all about a huge shift in how you think. It's about going from asking, hey, does it work? To asking, okay, how well does it work? And how can I prove it? This whole pro mindset boils down to something called evaluation-driven development. Now, if you've done any software engineering, that probably sounds a lot like test-driven development, and that's exactly where it comes from. The idea is so simple, but it changes everything. Before you even think about building, before you pick a model, you define exactly what success looks like and how you're going to measure it. So yeah, you're literally flipping the usual process on its head. Instead of building something and then saying, uh-oh, how do we test this? You start by designing the test. You're setting up the finish line before the race even starts. And that single change forces you to be so much more rigorous. It's what separates a fun hobby project from a real professional product. Okay, so if we're defining success first, we have to ask a pretty basic question. What does good even mean for an AI? Because I can tell you it's way, way more than just being accurate every now and then. For any serious app, you gotta go way beyond just accuracy. There are two absolute pillars you need to build on. First, factual consistency. Is the AI telling the truth? And second, safety. Is the AI going to cause any harm? Factual consistency is all about making sure the model is tethered to reality. This is absolutely critical if you're building anything with RAG, that's retrieval augmented generation. You know, where the AI is supposed to answer questions based only on documents you give it. You have to be sure it's actually using those facts and not just, well, making stuff up. And to give you an idea of the target here, check this out. On a major benchmark that tests how truthful a model is, human experts score about a 94%. So that's the bar. That's your goal. You're not aiming for mostly correct. You're trying to build something that's as reliable as a human expert in the field. And then there's the safety side, where the stakes are just as high, if not higher. You have to be testing constantly for all this stuff, because an AI that spits out hate speech or reinforces bad stereotypes or gives dangerous advice, that's not just a buggy product, that's a genuine danger that can cause real harm to people. And you know, these biases can be really subtle. Some fascinating studies have shown that different models can actually inherit political leanings from all the texts they were trained on. Like this chart shows, one study suggested GPT-4 leans a bit left libertarian, while Llama might lean more authoritarian. Now, the models aren't thinking this way. They're just reflecting patterns in the data they learned from, which is exactly why you have to test for it. All right, so we know what we need to test for: truthfulness, safety, bias. But how do you actually do it? Let's get into the toolbox that the pros use to really put these AI systems through their paces. One of the biggest tools in the box is benchmarks. Just think of them as standardized tests, like the SATs but for AI. They let you measure really specific things. MMLU, for example, is like a massive final exam across 57 different subjects. But then you have something like HelloSwag, which tests for common sense. You know, the stuff that's totally obvious to us, but AI can get hilariously wrong. Using these lets you get a real score and compare models apples to apples. But here's the catch. Automated tests can't see everything. At the end of the day, so many of the things we care about, like is it helpful, is it creative, is the tone right, are totally subjective. And that's why, as this quote says, human evaluation is the ultimate North Star. It's the final word on whether your AI is actually any good. And we are not talking about a few random checks. The scale here is industrial. Take LinkedIn. They have a team that manually reviews up to 500 AI conversations every single day. That's the only way they can catch those weird, subtle mistakes and make sure the user experience is actually good, something a benchmark could never tell you. And all of this brings us to our last and maybe most important point: Evaluation isn't a box you check before you launch. It's not a one-time thing. Because the AI models themselves are always changing, your testing has to be a continuous, ongoing process. This is a very long game. The reason why is this spooky phenomenon called model drift. It's the idea that a model's performance can change over time even if you do absolutely nothing to it. The company that makes the API might push an update, or the way users talk to your app might change, and boom, the model that was perfect yesterday is suddenly broken today. And this is not a theory, this actually happens. Check out this crazy example. A study found that in just 3 months, between March and June of 2023, GPT-4 got way better at certain math problems. But at the exact same time, its ability to generate code got way worse. The model's skills literally shifted under everyone's feet. If you weren't constantly testing, you would have no idea. So that really leaves us with the big final question. If the very heart of our applications, the AI model itself, can change without any warning, how on earth do we build systems that we can actually trust day in and day out? How do we make something that's truly reliable when the ground beneath us is always shifting? That's the challenge.